This is an overview video on some of the new features of ioGAS 7.1. First of all, let's look at the interface. We've added window ban options to the quick access toolbar, which lets you now minimize and close all open plot windows. We also now have a favorites list where you can create a menu of frequently used tools, which you can easily add to this list using right-click on any tool icon. We've moved the Save button and the file ribbon bar to be located next to Open. We've added select labels to the data ribbon bar, added centered log ratio as a quick transfer menu option, and we now have a dedicated ribbon for structural tools. And we also now have the option to browse to logs folder for technical support purposes. In the Select Variables dialog, you can now sort the list of columns by right-clicking on the list to the left. This list will be sorted by variable type and then alphabetically within each variable type. Median lines on two key box plots can now be displayed with a notch instead of a straight line running through the median. We've made some changes to the Attribute Manager. You can now click on headers to sort the items in the list alphabetically or by number of rows, and you can make multiple selections using the Shift key on your keyboard. This can be used to easily merge multiple attribute groups together. You can also select multiple attribute groups and turn them on and off at the same time. And let's look at XY plots and some of the new improvements that we've introduced in this release. You can now change the size of mean crosses on XY plots. The size of mean crosses line can be 1 or 2 standard deviation for each color group. And we've also added QA/QC guidelines around the y equals x line in XY plots. You can toggle between displaying 5, 10, and 20% guidelines and all three lines at the same time. QA/QC lines are also available in QQ plots. The 5, 10, and 20% guidelines can be displayed around the y equals x line of a QQ plot as well. And we've also decoupled the regression line tool from the toggle to display the y equals x line. As a result, you'll now be able to choose amongst different calculations for regression lines. The new plot type introduced in this release is the scatterbox. A scatterbox consists of a scatter plot in the middle with two box plots on either axis of the XY plot on its side. Outlier threshold lines, as per the two key box plots, can be toggled for color groups or for all data. You can then attribute data points that plot outside of these lines with unique shapes and sizes to mark them as outliers in your file. In this release, we have included the entire OSNACA dataset into ioGAS. I'm just going to open a classification diagram in order to display these nodes. The OSNACA dataset can be found within a new tab under the Mineral and Rock Composition tool. And the OSNACA tab itself is divided into sub-tabs for deposit types. And clicking on the reference button will bring up more details about each sample. The OSNACA nodes work in the same way as rock reference nodes. And these nodes can be displayed in an XY diagram such as this one and in other plots as well. And if you wish to know more information about each sample point, you can now display a text label on top of each point. By default, it uses what you have set in your sample ID field, but you can change this to use the first variable in the Select Labels tool. To view what column is used for your sample ID column, you can now open the column of this dialog without closing all of your open plot windows. And the next new plot type that we'll look at is the bar chart. The bar chart uses the color, shape, and size attribute groups in your file to display counts of samples within each group. And you can cycle through displaying between attribute types and see how shape and size attributes have stacked color attributes. With the latest provided resource update, we have been supplied with some templates and diagrams by OSPEC to use with Osiris spectral data. And this is a GAS file from the Osiris cloud which contains OSPEC spectral data. We can open one example of an Osiris classification diagram that we can use to auto-attribute our samples. In this example, the data points are colored based on where they plot within the calculated thresholds for the different chloride types present. Let's move on and look at some of the new features that we have added to the structural module. As mentioned at the start of the video, Structural Tools now has its own ribbon menu. And this file is from an IQ-Logger export and it contains alpha, beta, gamma angle readings. Our alpha beta conversion tool can take these measurements to convert into dip and dip direction values, and you'll need to know your drill hole orientation to configure the dialog accordingly. By default, it'll create columns called dip and dip direction if you don't have columns of that name in your file. And once you have these columns, you can now plot a stereo net. We have separated the structural configuration dialog from the plot itself, and setting save within this dialog is applied to any subsequent stereo nets. You can now place linear features on a stereo where they appear as a different symbol to user plane poles. And we've revamped the user planes and lines dialog where you can change their visual properties and add new features from within the same dialog. There's also an option here to change how planes are displayed. You can display them as poles, planes, or as both poles and planes. So among some of the things you can do visually is now you can change the color of a feature and its size on the plot. You can also change the symbol that is used for each linear feature to distinguish between each plotted lines. All of this information can be copied between StereoNet plots within each session or to a text file. All information within the dialog is retained when it's copied across, and you can copy both plane and linear features. Aside from user planes and lines, we can also plot user drill hole on a StereoNet based on its dip and azimuth. User drill holes follow our convention in which a positive dip value represents an upward pointing drill hole, and negative dip value will represent a downward plunging drill hole. You can copy user drill holes between the StereoNet plots. And we can now look at a brand new plot type, which is the rose plot. The rose plot is a way to visualize direction measurements, and it uses color attributes set in the attribute manager. The rose plot uses whatever is set in the structural configuration dialog, so it will display structural measurements along a 360-degree axis based on its dip direction. Structural readings are allocated to bin a certain size, and similar oriented features are stacked together in the same bin. You can toggle between showing only planar or linear data, and you can add or reduce the number of bins to adjust how many measurements are allocated within each bin. And you can cycle between displaying dip direction mode, or strike mode. In this release, we have added support for applying Vanta detection limits to imported XRF files from a Vanta. The CSV file is from one of our Vanta portable XRF machines, and the new detection limit can be found in the drop-down list in the importer dialog. The values outlined in this list are based from internal testing at Index. The last major feature that we will show you in this video is the Wavelet Tessellation tool. This is a gas file containing data from an easy gamma. The file has depth information and gamma reading for each row. Go to the Analysis menu to open the Wavelet tool, and the initial setup is similar to a downhole plot tool, where you first assign your hole ID and depth information columns to the appropriate fields. You'll then need to assign a variable to use as the signal column, which will be the gamma column. Wavelet Tessellation requires the data to be regularly spaced, and we provide the option to interpolate using a set depth spacing based on either half of the median or the median spacing. There's only one drill hole here, so just select and click OK. This will generate a scale space plot with the default view being a tessellated view of the wavelets. The blocks are colored by the mean variance for each group, and by default the blocks are colored using a linear color ramp, but you can change this to log or percentile coloring modes. The tessellation blocks are displayed with a 30% noise filter applied to it, which we will discuss shortly. I can choose to display the regularized signal column or the original signal column, or turn them off altogether to see just the tessellations. Wavelet tessellation is an integration of two analytical approaches for processing complex signals. This is a heat map display of the wavelet transform of the gamma signal with an overlay of transparent tessellation blocks. The tessellation blocks are filtered at 30% by default, and varying the filter size can reduce the complexity of the tessellation by merging the blocks at a lower scale. In a scale space plot, the blocks to the left of the plot represent small-scale spatial domains such as lithology units, while the larger scale boundaries to the right might relate to supersequences or stratigraphic units. So going back to looking at the colored tessellation blocks, these are colored by the mean variance. And what we can do now is save the block tessellation mean values to the file by dragging the red line on the plot. You will see the scale and depth changing. Click anywhere to save the tessellation mean values at the scale. The resulting mean values column is a numeric column, and it contains the tessellation mean value for each block at the chosen scale, seen here plotted as a downhole plot. So what you can do now is plot your gamma signal in another downhole plot. And you can then use the attribute manager to select the tessellation mean values column to auto-attribute your data points. You can see how each row is colored to the tessellation boundaries identified for that particular scale in a scale space plot. Another way that you can select the scale to generate the tessellation main column is via the sum of squares versus style counts plot. If you hover your cursor over each inflection point in the plot, you'll move the red slider across in the scale space plot, and the x-axis is the count of blocks at a particular scale. So here I have chosen a scale that will give me 20 blocks. And if you have done this workflow before and determined the filter percentage and scale required, it's possible to create the mean column without displaying the scale space plot. The batch mode allows you to type in the filter percentage and scale values and run the process for your selected grouping fields. And again, you can use the resulting column to auto-attribute your data points. Wavelet Oscillation is a useful tool that lets you turn a complex downhole signal into an interpretable pattern that can be related back to the geology, allowing you to delineate any natural boundaries that may exist within your data. This concludes our brief video on some of the new features of ioGAS 7.1. For further information, please see the full list of new features and improvements on our help file. And if you have any other questions, please feel free to contact us via our website.